What happens to your user experience when users run into network latency? They run into a problem where the experience is probably not a good experience, very bad experience. There are ways that you can improve this, testing what happens to your application under those poor network conditions, which you can simulate. You can simulate network latency using SpeedBump, which is a TCP proxy, which is a nice way, actually fairly straightforward way to introduce latency for your API calls that are made within your application. SpeedBump is great. It allows you to sort of configure the variable latency, and it gives you a lot of options. It's written in Go, which means it can compile basically to any OS. The good part is that it's they include a Docker container, so they make it even easier to set up for you. They do provide a way to download the binaries directly into a release for whichever platform you're running. Though I would just say, yeah, you could just run it directly like this. Though I like the Docker approach better because you don't have to worry about any of the other things. You don't need any of the build tools. You just download the Docker container directly. Copy this command here and then paste that in your terminal. Make sure Docker's running, and then it will start up a server running it looks like port 2000, and it forwards on to your local host. Or is it the other way around? Let me double check this really quick. Yep. Okay. So, yeah. Spawns a new instance listening in port 2000, and it forwards traffic to port 80. And this could be any address. It could be an API endpoint, for example, like you already have a public API endpoint. You can put that there as the host and port, and then this proxy will simulate latency. Actually, it'll inject latency into those APIs so you can test what latency looks like for your applications, and it will give you that end user experience that your users will probably run into under various network conditions. When we're testing for network latency within our application, SpeedBump, it gives us a lot of configuration options. We're going to walk through a couple of those configuration options. So what they did is they wrote a TCP proxy written in Go, and it simulates variable network latency. Not just like a fixed amount, although you could say always at 2 seconds latency to see kind of what that looks like. But you could also simulate and modulate that latency over time. So all you could do, my favorite approach is just grabbing the Docker container one-liner here. There is a latency option. This option right here is going to be the default minimum. So it says every single time I invoke an API call on port 2000, on my local system, it's going to proxy that over to whatever host I put here. It could be any website or API endpoint, or a local like Node.js container or a Django container. And then that latency is always going to be a minimum of 100 milliseconds. You can modulate that and sort of make that variable by adding an amplitude. And there's a sinusoidal wave amplitude, 100 milliseconds. And you can set the period, so how quickly the highs and lows of that sine wave add additional latency over 1 minute. So base latency at 100 milliseconds, and it added 100 milliseconds at the maximum amplitude. So that'll be 200 milliseconds under the worst conditions with this configuration. There is also a SAW amplitude. So it's more of a linear amplitude. It will just gradually increase that latency until it hits 200. So in this example, we have a base of 300 milliseconds plus a SAW amplitude of 200 milliseconds. So it'll start at 0 and then go to 200 at a period of 2 minutes. So at around the 2 minute mark, it'll be at 200 milliseconds. Added on to 300, we should see 500 milliseconds. So you see, this is what that wave looks like. So it'll bounce between 500 milliseconds and 300 milliseconds. you can combine those for a sinusoidal and that's crazy. Okay, so base latency of 300 milliseconds, a SAW amplitude of 200 milliseconds over a period of 2 minutes, and a sine amplitude of 100. So it looks like the maximum, it looks like 500 milliseconds in this case, with a base of 300. There's also a triangle amplitude and a square amplitude. Oh, okay, so it'll pop up and pop down, or instead of, it goes directly up and down with a triangle, as opposed to, like, this is a sawtooth where it immediately drops to 0 and drops to 0. You could also have a triangle where it goes, and it goes up and down evenly. Neat! So they give you some pretty cool options on how to modulate the latency. And there are a couple other configurations here. You could simply leave those as default. If you need to increase these, looks like these are the defaults. You could increase them if needed if you have larger payloads or of the sorts. You probably don't need to change these, but you could if you wanted to. Let's try it out. Let's try adding in latency into our application. We'll do this using their Docker container with the SpeedBump TCP proxy to simulate latency. Actually, I would say it's more than just simulation. It's actually introducing simulation into your application, which is important because we could use this to sort of test what that user experience is going to be within your application when the latencies get really bad. And so what I've done here is I've taken their examples and I've put together a command that demonstrates this over a shorter period, because what we're looking at is multiple minutes of a window of how we want, but I want to test that a little more quickly. I want to see the latency effect faster. So what I've done is I've just set up a curl and a Docker run command here in my terminal. Here we go. So I've got myself a Docker command. I'm going to be able to access that. You can also set this up to point to a network host container, so that way within your Docker ecosystem on your local laptop, you'll be able to access this latency when you're testing within your application while running in Docker. However, in this case, I want to run like a client app that is accessible from my laptop. So I just say I'm going to be mapping ports 2000 because I'm exposing port 2000 internally, and I want to map that out to my local host. So I do this -p in there. I set the image to be the SpeedBump latest. The base foundation latency is 300 milliseconds, so it'll always add 300 milliseconds. And then I'm gonna grow it to an additional 1 second over the period of about 6 seconds. So every 6 seconds, it's gonna go up and down, adding that 1 second variation. So I'll get that started. So now it's up and running, and now all I have to do is point my API calls to localhost on port 2000. So I set up a nice little while loop. I said HTTP port 2000, the API call, and since the target host is a PubNub API, we'll be able to be accessing a public API and test the latency with that. So about 3 times per second, I'm going to be running this test. Let's go ahead and do that real quick. So as you can see here, it is going to be modulating latency. So it goes pretty fast with, a foundation of 300 milliseconds all the way up to about a second. So it gets pretty fast there, it gets a little bit slow, gets slower, and then it gets fast again. So it's kind of doing this over a period of 6 seconds. So it's working. It's doing what it said it was gonna do, sort of modulating that latency. And so what you can do is you can take these to the extreme to really see what happens under like the worst possible conditions, which happens in the real world. Often networks can go down, latency can increase due to various conditions. And what we can do is test those conditions using SpeedBump, and they make it fairly straightforward. Just this one command will give you access into adding latency into your API calls. And the great thing is you can do this in a web browser. This could be in your Next.js app, your React, your React Native. Any kind of front end can also access this tool. And if you're building server-side applications and you want to test an API or latency between containers, you can add this container as well as sort of like a test proxy container into your sort of like a compose, and you'll always have that extra latency test advantage. And this could just be part of your CI system even. That's actually a good idea. We can introduce intended latency. This is a pretty standard, you need to add this into your system as a part of a way of testing, because you're gonna run into various network latencies over time, and it's really great to be able to be prepared for these conditions. Because what you can do is you can add additional code logic to be prepared for those conditions to say, oh, network latency, I see it's going a little bit slow. At least give the user some heads up, because you don't want the user just sitting there waiting. They want to be able to understand what's going on, or you need to log it. There's like a lot of scenarios of testing that can occur here that can improve the user experience just by simulating network latency.